Hello, welcome back. Thanks for joining us on this Windows Server 2016 course. I'm still Matt McSpirit.
Corey Hines?
Still?
Still?
Sure?
Positive?
Excellent.
We may switch later.
No, we won't. And in this module, we're going to be focused on super duper software-defined networking. I don't think I've ever used that combination of terms in my life.
I would be embarrassed if I were you.
There you go. But this is software-defined networking in Windows Server 2016 preview. And it builds on what we talked about with storage in the sense that we are changing the way you deploy, manage, run the network infrastructure. Just like we talked about deploying storage differently, and instead of doing the traditional route of SAN and iSCSI fiber channel or whatever it may be, taking a different approach and using software to transform what is very much a traditional physical component of the data center. So networking is no different, albeit it's probably a little bit more complex. Now, if it's really late in the morning or really late at night or really early in the morning for you, you may struggle. So don't worry, the content is on demand later. So just like the previous module, we'll do a quick story so far, and then I'm going to dive into some of the core network services. What's new? Network function virtualization. What is that? So we'll explain what that's all about. Some of the foundational, some of the offload enhancements we've made, where we're working closely with the network adapter vendors to really deliver extremely high performance, utilizing what they build in their silicon to really offload a lot of the key networking tasks into the underlying fabric. Some management stuff with a new network controller, and similar again, we'll wrap up with some resources. So where have we come from? Well, today it's a reasonably complex picture on first look. You've got your on-premises infrastructure in this big blue cloud at the bottom there, and there's a number of components there. Firstly, you've got your physical network switches down here, and these physical network switches, System Center through OMI, which is standards-based protocol, can help you to manage those top-of-rack, those aggregation switches, and control those as part of your overall management infrastructure. In addition, it will help you deploy and manage the Hyper-V switch. The Hyper-V switch is essentially what gets deployed to each Hyper-V host to allow virtual machines on that host to communicate out of that host.
So just kind of one point on that.
Yep.
When you talk about OMI for switch management, one of the more useful sort of ways of thinking about this is right now if you have multi-vendor switches and you want to go in and enable disable ports or define VLANs, you typically got to either use their CLI, their CLI interface, or log onto their portal and make the changes.
Yep.
And if it's one vendor very different from the other vendor, by both of them supporting OMI, you can do things like define a VLAN in PowerShell and just say, do it to that switch and do it to that switch. Yep. And they can be different vendor switches as long as they support the protocol.
So it gives you that centralized.
Exactly, and that's what things like VMM are using to do these kinds of tasks.
Great, okay, cool, great extra context. So that's the OMI for the physical switches, but Hyper-V extensible switch is, like I said, that virtual switch that gets deployed to the host, or all your hosts, depending on VMM, is very flexible at how it deploys those switches across the data center. And from there, you can also bolt in additional extensions because it's a Hyper-V extensible switch. So there are solutions from the likes of Cisco, NEC, Five9, Inmon for traffic monitoring. There's all sorts of plugins that plug into this virtual switch that provide additional functionality, from agentless antivirus to the Nexus 1000V to OpenFlow to agentless a virtual firewall as well, all sorts of stuff that bolts in. In addition to that, so we've got the Hyper-V extensible switch, there's also this idea of network virtualization. So instead of using VLANs to segregate all of your different networks within your infrastructure, let's use virtual networks, using the same concept that we are physical server, virtual machines, physical network, virtual networks. And these networks are encapsulated from one another using NVGRE, so network virtualization generic route encapsulation, or route encapsulation. There you go.
That's kind of blended. One of the use cases for this that I think people relate to a little bit is a mergers and acquisition scenario. So let's say that you have a company and you buy two other companies, and these two other companies have a bunch of different servers and whatnot in their buildings, and you go, well, we want to optimize all this. So you take all their servers and you can run VMs. Okay, and that's step one. And then they go, well, I want to take all these VMs that are now out in all their buildings and move them to one central data center. Well, in order to have a fabric that spans everything, that you can load balance everything across, and have all these different companies living on it at the same time, it's kind of multi-tenant, even though it's one company. You can use network virtualization to say, I'm going to lift the VMs from company A and drop them on my fabric, and I don't got to re-IP address anything. I'm going to lift VMs from company B and drop them on my fabric, and I don't got to re-IP address any of those. They could even be the same. They could even be conflicting, but network virtualization lets them live within their own bubble, provides an ingress and egress point in and out so that traffic can go into these virtual networks, out of these virtual networks, and then across, out to the public internet or wherever it's going to go.
Yeah.
And so you wind up having multiple conflicting, layered, duplicate, whatever subnets that are able to live on the same set of hosts.
Yeah, and that's the power of network virtualization. It gives those same kind of isolation benefits as VLANs, but it's all defined in software. It's all controlled through System Center. The plumbing is within Windows Server. But the nice thing about network virtualization, as I'll show in a quick demo, is it's so easy to deploy new virtual networks. They utilize a new component we introduced in 2012 R2 called the Virtual Network Gateway, which is a role of Windows Server. We pre-package this as a template so you can speedily deploy it into your environment. And that allows you to do, like Corey said, to break out of the network, the virtual network, onto the internet or onto the LAN, however you've got it configured. The beauty of virtual networks is the scale. Even the top-end switches in the world, 4,095 VLANs as a maximum. Network virtualization, 16 million virtual networks from a scale perspective. You're not going to run out. So for service providers, for large enterprises, yes, you're probably not going to hit, I would almost say inevitably not going to hit those numbers, but just let's create a new network, create a new network.
And the flexibility you get, because if I have a virtual network that's running over on a host and all of a sudden those VMs need more resources, I can now spread those VMs across many hosts without having to go to my switches and make sure those VLANs are plumbed through.
Yep.
Because the network exists as a bubble within the fabric, and Hyper-V takes care of doing what the VLANs would have essentially done, which is route the traffic from VM1 to VM2 over on this host over here in this other building, as long as it's on the same basic fabric.
Yeah. So if we look through some of the plumbing that exists within this environment on the slide here, so we've got our data center infrastructure. On top of that, we've got in a typical data center, you've got switches, routers at the spine. You've got appliances that may be providing additional functionality like hardware firewall, hardware load balancer. You've got routers to get out of the environment as well. All of these components need their independent configuration, management, and so on. And when we collapse that and call that the plumbing, that's the physical infrastructure under the covers, network virtualization can sit on top of that. So we utilize that underlying plumbing to really bring to life more flexibility and streamlined agility on top through Windows Server, through System Center, and through learnings we made in Azure. So if we bring some of these core services on top, core services like DNS, DHCP that you're familiar with, the ability to route between these different networks, isolation through network virtualization, switching through the Hyper-V hosts, and also IP address management, IPAM. All of these are core services provided by Windows Server within the environment. And then on top of that, we bring some of the edge services, some of the advanced functionality that allows our network infrastructure, our virtual network infrastructure, to get to another destination, whether that's site-to-site VPN, whether that's NAT through a gateway, whether that's a more direct connection to Azure through ExpressRoute. Whichever one you choose, they're integrated with the Windows Server Gateway platform to enable you to break out of those virtual networks and plumb off to other locations securely and efficiently for high performance, for just network connectivity from a hoster to your data center, whatever it may be. And then we think about some of the services that layer on top that benefit from this. So you've got Azure-based services coming in there, so sitting on top with the Azure Pack, and Virtual Machine Manager providing the control, the management, the monitoring of this infrastructure. So all of those components with System Center and Windows Server combine to enable us to deliver a lot of functionality and deploy our applications efficiently anywhere in the data center. So here you'll see I've got a multi-tier line of business application, which is made up of multiple back-end virtual machines on a particular subnet, a middle tier, an application tier perhaps, that's on a different subnet, and that's across Windows and Linux. You've got a front-end tier that's providing the front end for the application, and these need to be connected together through switching, routing, and so on. We can model all of that as a multi-tier application within System Center, add in additional functionality that maybe we need to NAT out from there, we need to apply VPN or ExpressRoute to connect to Azure. Either way, we can model this application and deploy it efficiently as a service within our data center, all done in software sitting on that underlying plumbing that we've defined or that we're using through Windows Server and System Center.
Now, it's fair to say for the average Windows admin, this is a big leap forward.
Huge.
Because if you think about the way storage has traditionally been, the storage guys do storage.
Yep.
And we're now getting to the point where the storage guys are being comfortable with Windows handling storage because Windows is providing very, very robust storage solutions. Well, now Windows is also providing the stuff the networking guys did. So the VLANs and the port ACLs, the way routing happens, the way that configurations for load balancers and firewalls, VMM, Virtual Machine Manager, can now do a lot of that. So rather than you going onto the firewall, going onto the load balancer, going into the switch, going into the router, you now don't touch those devices. You let System Center manage those devices, and the work that was traditionally done with those devices' proprietary tools is now done within the Virtual Machine Manager UI. And so it's a big leap for a lot of organizations that also don't believe they have or need the complexity for something like this. And the reality is, what you were showing here looks very complicated. There's a lot of lines and boosts moving around. It doesn't have to be that complicated, though.
No.
And when you see it within Virtual Machine Manager, it looks a lot simpler.
Yeah, I'll show that in a second as well. But to illustrate the point of flexibility, you've got that line of business service. And if you look here, you've got the graphic where there's 2 data centers, right and left, 1 and 2 on the right-hand side or in the middle as well. And you've got Azure. The flexibility of packaging up these services and having the consistency to connect all of these resources, it enables you a lot more flexibility to move things around as necessary, because you're running that virtualized network. Doesn't matter where you move it, as Corey said, you've got the flexibility to still connect to it and everything still communicates. So I wanted to give you a quick demo into my environment. So here we are in system. Remember, this is actually technical preview 2 of VMM, but it's managing a 2012 R2 infrastructure. And what you'll see, I'm on the VMs and services view in the VM networks option here. And you'll see I've got a network for a company, pretend I'm a service provider. I've got a network for Contoso, I've got a network for Fabricam, I've got a network for Tailspin Toys.
These could be acquisitions?
Could be acquisitions, yeah. I mean, I'm a growing company, what can I say? You'll see this particular Contoso virtual network has 2 IP pools, which means VMM is handling IP address distribution as well.
So it's not DHCP, but you kind of got to think about it like DHCP.
Yeah.
That VMM is going to now allocate IP addresses to VMs as they come up, in the way that DHCP would.
Well, if I was a hoster and somebody was buying a VM for me, I can't expect them to buy a DHCP server as well. I've got to somehow give them network connectivity. So this is my way of doing that. So
I'm not using Excel to see which customers have which IP addresses.
No, not yet. So if I look at VM networks, I want to show you how easy it is to create a VM network that spans my entire data center. So I'm going to create a VM network. I'm going to call this Jumpstart. I'm going to put it on my logical network, which is the underlying plumbing that's going to support this VM network that I'm creating. And the important thing here is I just need my hosts, my Hyper-V hosts, to be attached to this logical network, and it needs to be routable. Because if you think about it, if I create this VM network and I've got a VM that's in the Jumpstart network that's running on host 1, and I've got another VM that's in the Jumpstart network that's running on host 5, to send information between one another, those 2 VMs, they've got the traffic, the packets have to actually get from host 1 to host 5 and back. So there has to be some plumbing to get there.
In a classic data center, someone would go in and build VLAN trees to connect those 2 hosts together and put a whole lot of NICs in the host.
Exactly.
And what we're saying is you can do away with these complex VLAN deployments and say, here's one flat network that the entire data center spans, and all the stuff that would have ordinarily been isolated by VLANs can now be isolated by logical networks. Yep.
So I'm going to carry on creating this. So next, and then isolation. I'm going to isolate this particular VM network called Jumpstart from other VM networks like Contoso, Fabricam, and so on, using network virtualization. I'm going to add a subnet. So we'll call this subnet, and I'm going to call this 192.168.2.0. So quite a small subnet. We'll go next. Connectivity. Do I want to allow this Jumpstart network to get out to the internet, so workloads on this Jumpstart network to be able to connect out somewhere? Now I can enable VPN tunnels. I haven't set that up. I'm just going to use NAT, which means this gateway that I'm going to select here will essentially translate my VM workloads inside this VM network and allow them to communicate out on my public IP that I've got. So it's almost like a direct pipe, a clean pipe just for my tenants to get out to the internet. They're not going to touch my core infrastructure, because if I'm a service provider, I don't want that. I want them to have internet access, but I don't want them to get back to my management infrastructure. So I'm just going to click next on all of these and finish. And just like that, how many clicks was that? Oops, what's going on here? Non-negative.
I'm going to be nice and not say a thing.
Well, it doesn't matter because I've got some that I created earlier. It's fine. Here we go. There's Jumpstart. It got created. I think it's just the gateway. So let me try this one again. And NAT2, let's try that one. Is it going to work this time? Either way, the end result is the same. We've got a virtual network that's there for workloads to use. See, I think that one worked.
No, the trick was you just clicked harder.
I did actually. This mouse is now broken. So there we go. That's my Jumpstart network. So you saw how easy it was for me in software to create a new network. If I look at this Contoso Dev one and IP and test one I created earlier, they're on different subnets, part of the same VM network. And the beauty of that is network virtualization will handle the routing between those as well. So if I've got a VM deployed to dev and a VM deployed to test, I'll be able to ping between them, communicate between them, even though they're on different subnets. And I've not specified a DHCP server. I've not deployed any specialized switching or routing within those virtual networks. It just gets handled as part of network virtualization. So that was just a very quick demonstration of how we're using that today. But I want to fast forward and understand what we're doing in the future. Are you nearly set for your IPAM, or am I doing IPAM?
Oh, you're doing IPAM.
Oh, great. Excellent. Right. So we talked about those core services before. Switching, DNS, DHCP isolation, routing, and so on. IPAM has had some significant upgrades in 2012 R2 and 2016. If you're not familiar with IPAM, IPAM is a way for you to leave behind managing your IP address management in Excel spreadsheets. So managing IPs through a dedicated experience, integrating with DNS, DHCP, providing custom IP address space display reporting, management, auditing, role-based administration, who can access what within the IP address management side. And it really does give you a very granular level of control for your network infrastructure.
So think of this as a layer of management that sits on top of DNS, DHCP, Active Directory, and your virtual networks to give you one view that shows, hey, how's IP address consumption doing across all 50 of my DHCP servers and all my subnets? Do I have a subnet that's running out of IP addresses? Do I need to go check my individual DHCP servers and see if they're healthy? Are all my DNS zones healthy? And rather than you having to check individual devices or rely on, management software, IPAM is that sort of intermediate layer between something like, Operations Manager and just the management consoles to give you a global view of everything.
Yeah. Good, Phil. I was just setting up my IPAM VM there. Excellent.
I got you back.
So you have, absolutely. So just wrapping up IPAM for a sec, there's a lot that it does. So Windows Server 2016, it's unified IP address management across physical and virtual. That's what that unified means. So it's not just about, okay, you've got a traditional physical infrastructure, and you don't need to be using virtualized networking like we just illustrated to benefit from IPAM. Absolutely not. You can utilize in a purely physical environment.
DHCP servers, you benefit from IPAM.
Yeah. And it's
because you have one place to go to see how both servers are doing.
Yeah, just a role of Windows Server, a capability you enable, or is it a feature? I think it might be a feature, actually. Either way, you enable it within Windows Server. It can integrate with System Center Virtual Machine Manager if you do want that view of logical networking, virtual networking, and physical networking.
One tip on IPAM, having deployed it,
only one,
requires patience. Well, if there is one tip, that's the tip, because it based on, when you deploy IPAM, it uses a job framework where it deploys jobs into the task services of each of the hosts it's going to manage. So you're going to deploy IPAM and say, hey, manage this DHCP server over here. It's going to put a Windows task, scheduled task, on the machine to run and collect the data, and then it's going to report that data back. So you deploy it, it's not going to be instantaneous, instant gratification. All of a sudden it's full of data. You just need a little bit of patience, give it time to
multiple steps,
to run these logs, collect the data, bring it back. And as you kind of work through it, you'll experience that. But patience is a virtue when you're setting it up.
And one of the key new features, especially if you are running a mixed environment, is cross-AD support. So you can now aggregate a lot more infrastructures into a single view and very much start to understand and break down what's going on. And also, RBAC enables you, so role-based administration, role-based access controls, enable you to manage an IP address space, DHCP and DNS. So different people can have different responsibilities, and you're not giving the keys to the castle to everybody. So you can be quite granular like that. But if we duck into my environment and I bring up my IPAM machine, if I go to that overview, this is somewhat relating to what Corey was talking about. The quick start is actually 6 steps, some of which involve you doing something, some of which just take a few minutes to pull back information. And you'll see these scheduled tasks down here that may or may not be run depending on which task is getting executed at whatever time. But once you've set up, it starts to pull back a lot more information. There's some good guidance on TechNet on how to do that. But you'll see I've got a couple of machines. I've got 2 domain controllers. I've got a DHCP. I'm not interested in this WDS. I've unmanaged that, so I've chosen it to not report any information on there. But if we look at what it returns from an IP address space, if we look at my IP address blocks, in my physical world, my purely physical world, it's saying, okay, you've got plenty of space left in this particular scope or this subnet, so it's underutilized at the moment. I've actually got assigned addresses just 76. I've got 256 available, so it's really giving me useful metrics about the IP address usage. And if I look at my inventory, I don't know if there's going to be much in there. If I look at the address range, yep, same kind of information, 100 to 175. It's managed by Microsoft DHCP. That's the server it's come from.
The groups would represent things like, here's all the subnets in this building or this site. So you can kind of look at, how's the downtown building looking? How's the, across the lake building looking?
Yeah.
That's what those groups are used for.
You can see a lot of information about it, start IP, end IP. Is it virtualized? No. Is it used for calculations? Yes. What's the scope name and so on? And I can, as I start to go down to perhaps DHCP scopes on the left here, I can start to actually bring about change. So I don't need to go to DHCP and make this change. I can do it right here. So that's pretty useful. Same with DNS nodes, same with DNS itself. So I can see my DNS servers and the DHCP server present there as well, because I'm looking at both. But here's the virtualized IP address space we were talking about before. So you can see I've got a lot of virtual machines deployed. I can see duplicates. No, everything's healthy, everything's green, not expired. It's integrated with System Center Virtual Machine Manager. This is exactly the same environment we saw before. So you'll see I get a view of my IPs that have been deployed. If I scroll down here, you'll see that 9.3 is actually, which VM is this? It's this particular service. Yeah, okay, is there anything else relevant? It's on the infrastructure VM's logical network managed by VMM. If I scroll, let's pick another at random, then at 11. If I look at DNS, you'll see it gives me more information about what's going on within the environment. If I look at subnets, you'll see I'm managing quite a few. There's the Contoso test, there's Contoso dev, there's Fabricam. I wonder if Jumpstart, I didn't create the IP pool for Jumpstart, but that would appear at next refresh as well. The key takeaway, and it says here, okay, this is a network virtualization, this is another logical network. I'm just getting that overarching view of what's going on in my...
Yeah, you're not going to DNS, going to DHCP on
Correct.
5 or 6 servers, going into VMM, pulling out a sheet of paper and going, okay, what do I have here, what do I have here, and making sure everything is healthy. You just, one place you go, and if nothing else, you go look at it and you see green, you're good.
Yeah.
You can go manage it with the source tools if you want to, but you can also do a lot of management directly with IPAM as well.
Yep. So what about network function virtualization? What is that all about? It's a topic that at first glance you think, okay, is this network virtualization? But you've just shoved the word function in there. What's going on? Network function virtualization, if you think about network functions in your environment, what functions do you have being provided by either hardware or software today? Well, if you think about some of these, you think about load balancers, you think about firewalls, you think about routers and switches. They're all, whether they're virtual or physical, they're all providing functions to the network. So if we look at the graphic here, and we layer this on top, some of the network services that are now included within Windows Server 2016. So we saw some of old, so NAT, site-to-site, VPN, gateway, express route for connection into, direct connection into Azure. Some of these others like load balancer and firewall and service chaining, these are all examples of network functions that we will, in 2016, virtualize for you and provide either as appliances or just capabilities built into the platform. So you think about load balancer, and we'll talk about some of these in more depth, but this isn't the NLB of today, of 2012, 2012 R2 and past. This is very different. The load balancer is something that's been pioneered and deployed in Azure, and we're bringing that capability directly into Windows Server. So it's been tested at hyperscale. It's now available in Windows Server for your use for load balancing your application access. The firewall is very similar, bringing it on premises. And if we look at some of the list of what you can expect from, in general, network functions, firewall AV, WAN optimizers, site-to-site gateway, router switches, load balancers, you get the idea. But virtual appliances are a typical way in the ecosystem in general that these functions are being provided. And Windows Server 2016 and its networking stack has been designed to embrace these virtual appliances, not just for running them on Hyper-V, but also for integrating them with the management stack within the network offering within Windows Server 2016.
Many of these virtual appliances can be run in VMs.
Yeah.
There's simply software solutions that run on either Linux or Windows and can run in VMs.
I'd assume a virtual appliance would be a VM, though, wouldn't it?
True, fair enough.
Right.
And a lot of these, quite frankly, you can get in the Azure Marketplace to run on Azure.
It's a good example,
So you can go up on Azure and get, from different vendors and different companies, virtual appliances you can add to your Azure subnets to add functionality to your Azure deployment, whether it be intrusion detection or firewall or optimization or load balancing or whatever. It's that same degree of functionality coming down to Windows Server.
Yep, and then a virtual appliance might not just be one VM. It might be multiple stretched. I mean, the load balancer is a good example. You wouldn't have a single virtual appliance load balancer because there wouldn't be much point. You need more than one to distribute the load back to to provide redundancy as well. It can be more than one VM packaged and updated as a single unit, and it means obviously you can then scale up, scale down. I need to satisfy more demand. I'll add extra VMs to this. I need to reduce demand to reduce consumption. Okay, fine. I'll remove some of those virtual workloads as well. And we did include a virtual appliance with 2012 R2, and it was that gateway I was talking about before, the network virtualization gateway, that allowed virtual networks to communicate out to the internet, for example, using that NAT capability. So when we think about some of the examples and where this all fits together architecturally, so you've got this idea that the Hyper-V host runs a number of these integrated components, some features, functionality, firewall, software load balancer agent. These are built into the Hyper-V layer, into the Hyper-V switching technology. But in addition, these are powered by and controlled by, more specifically, the network controller. So for instance, if you wanted to, and we'll get to the network controller a bit later on, but the network controller is your single point of control where you say, okay, I want to apply a software load balancing policy, go. And the network controller talks to the software load balancer appliances that you've deployed and configures them how you want them to be configured. The same goes for the firewall. I want to deploy this firewall ACL, this 5-tuple rule across all of my Hyper-V hosts or across these VMs specifically perhaps, go. And the network controller talks to the distributed firewall and makes that happen and communicates that down to the Hyper-V firewall capabilities and APIs within the Hyper-V layer. So you've got this very rich in-switch capability, but then you've also got this control mechanism in the network controller that's driving all of these appliances through its it's kind of like the OMI example we used before. OMI being a standard, you plug against the network controller and that handles controlling all of these other components. So if we think about this from a graphic perspective, yes, we provide key virtualized network functions with Windows Server, the gateway, Hyper-V network virtualization gateway, load balancer, site-to-site gateway. You can deploy virtual appliances from vendors of your choice. So if, like Corey said, on the Azure Marketplace, there's lots of appliances there. There may be ones you want to deploy on premises as well. You've got the flexibility. And you deploy, configure, and manage those using the network controller, which we'll get to a bit later on. And the Hyper-V host can host the virtual appliances that you need. So if you've got Linux-based appliances, Hyper-V can run those. If you've got Windows-based appliances, like the ones that are built in, Hyper-V can obviously run those as well. So when we think about one of those key things, and I mentioned earlier that the software load balancer that's built into Windows Server is not the network load balancer of old. This is very, very different.
Thank God.
This is very different indeed. This has been proven with Azure, scale out to many what are called multiplexer or MUXes instances. So for instance, for redundancy, for scale, you would have multiple of these SLB MUXes distributed across your Hyper-V hosts. Unlike 2012 R2, the gateway, the appliances don't have to live on a specific host. They can distribute around. The intelligence is there. We can move them flexibly. You wouldn't obviously combine them all into the same host because that's not really redundant. And obviously, if you lost that host, you would lose your load balancing front end. So you would distribute them accordingly. But that software load balancer that's been proven in Azure, battle-tested at hyperscale, bringing it on premises now, building it into Windows Server to enable you to embrace that now, and give you the scale
would you say
performance.
Would this be a fair, just thinking of, trying to absorb all this, would you say it's a fair assessment to say, in the past, building these complex data centers, we have lots of cables going into servers because all the cables have different roles. Now, we have one big pipe going into the server. And that pipe has enough bandwidth to handle whatever gets thrown on it. And all these different kinds of traffic, we no longer worry about, do I have a cable for that or a cable for that? We just go, hey, let's put a lot of bandwidth into the server and let the software take care of moving the traffic accordingly. Yeah, and there's a lot of intricacies around isolating those traffic types across the single pipe, which is completely doable in software, and using network virtualization as an example from the VM out. So you can provide QoS type services. Correct. Yeah, for different traffic types, whether it's SMB, TCP/IP, whatever it may be, and there's lots of, you could do it on a port or a specific traffic type basis as well. So when we think about some of the other benefits of this software load balancer, remember that's built in, it's tested at scale, it's multi-tenant supported,
allows you to access and provides easy management and control through that network controller, deployment through Virtual Machine Manager, which will be a capability as we go forward. And because it's got REST APIs or PowerShell, it can easily plug into existing investments you've made, perhaps in dedicated tenant portals or other management experiences you may have within your environment that have been bespokely built by you. So, very performant, very scalable. Do not associate this with the NLB. It's a very, very different proposition and allows you to provide a very, very powerful, scalable software load balancing for your key applications and workloads. And it's built into Windows Server, which is awesome. And another key area, not just about load balancing, but also protection. So firewall is an important integral part of protecting your infrastructure. And we're not just talking the Windows Server firewall here. We're talking a true built-in distributed firewall capability that allows you to deploy policies, 5-tuple.
Now, so you say 5-tuple. For someone that doesn't know what that means.
So you're essentially saying, okay, I would like this policy to represent a protocol, so perhaps it's TCP/IP or TCP or SMB or whatever it may be. The source and destination ports that can communicate with this rule.
Like the web server is port 80 from a random.
Yeah, source and destination IP, so from and to. And it's stateful, it's multi-tenant, so if you're a service provider, this is a very scalable, powerful multi-tenant solution.
So we can assign the rule to a particular tenant.
Yeah, exactly, essentially, and that's controlled again through that network controller, and it's deployed down to the Hyper-V virtual switch. So you're able to very much define these rules in a familiar way that won't be too dissimilar from rules you've applied in the past. Remember, it's only asking for those key things.
Yeah, I mean, if you've configured, switch ACLs, or you've configured router ACLs, or you configured, most production firewalls, this is exactly the same thing. Yeah,
so if you're looking to say, okay, very quickly, I need to stop all of these VMs on this subnet from communicating, go. A very quick rule, deploy through the network controller across to all of the relevant VMs that this affects. And that's very powerful. And the beauty of having this as a distributed firewall is if VMs float around the infrastructure, you've got the ability to take that firewall settings and policies with the virtual machines. So that's very, very important. As we said, it's scalable, it's manageable, diagnosable, so we can very easily query and understand what's going on in the environment. And the key one is being able to move those virtual workloads to different compute hosts without breaking tenant firewall policies. So as I've shown on the graphic there, the vSwitches that exist within each host, we're able to deploy the firewall to each one of those and configure on a VM by VM or port by port basis specifically, enabling us to very much provide that granular control over what can get in, what can get out, the traffic types, and so on. And really, it doesn't matter on the guest, whether it's Windows, Linux, whatever, you've got that flexibility built in with the firewall. And again, shipping through in Windows Server 2016. So when we think about driving highest levels of performance in the network stack, there are new innovations built into Windows Server 2016 that drive incredible levels of performance. One of those is RDMA, so Remote Device Memory Access, a capability that offloads a lot of key capabilities to hardware and allows the hardware to transmit packets at incredible speed without impacting CPU and memory on the actual host system. And we've seen that in SMB.
This gets, all these hardware acceleration technologies that are in networking for Hyper-V, number one, it just uses them. There's typically very little configuration. If you have a network adapter that supports TCP offload, RDMA, things of that nature, it will just use it. And it's all about just reducing the CPU load, maximizing the throughput. And there's very little configuration you actually have to do in any of these, right? If the capability is there in the hardware, the software will just know how to use it and will simply use it.
Yeah, exactly. And that's one of the key things is if you can take advantage of the hardware, it's always going to be higher performance, where we offload those key things. So if we look at some of the key offloads within the stack and what was offered in 2012 R2 and what's going forward, you've got things like RDMA, so being able to offload that processing of traffic to the network adapter for extremely high performance for live migration, for storage access, and so on. You've got VMQ for accelerating virtual machine traffic. You've got RSS for utilizing the cores in the host system to process traffic more effectively. You've got VRSS, which transmits that into a virtual machine, so allows you to realize greater levels of bandwidth inside the VM as well. Large send offload, receive send coalescing, TCP chimney, all of these things you'll see in the properties of the NICs. You make a decision whether you need those or not. A lot of them are on by default.
There's kind of a rule of thumb you can follow as well, which is If you're running 1 gig, very few of these things are going to matter because you're not pushing enough traffic, quite honestly. But if you start going above 10 gig, all our data center fabric's 40 gig, you very quickly see a hit on the CPU of the host when you don't have some of these features. When you have some of these features in the NICs, you turn them on, and now you're pushing that much traffic through. Things like RDMA, things like receive side scaling and VRSS. You see the CPU usage go down, which means the VMs and everything else runs faster. And when you're talking about doing your storage over, typical Ethernet type connectivity, matters even more. So a lot of these features, you might, you think about them and you go, well, I have a NIC that supports the VMQ and all these different features. I'm not seeing a difference unless you're, above 10 gig of throughput. You're not going to see a difference.
Right.
But when you start getting up to those scales, it really does matter.
Okay, so to bring it into more perspective, especially that RDMA example, on the slide here, we've got a view of Windows Server 2012 R2, and we'll compare it and contrast it with my randomly placed graphic that hasn't animated. I've included that bit on the animation to the right. So ignore on the right half of the graphic for now. But on the left-hand side, we've got a view of a host. You've got the management OS. You've got 2 RDMA NICs for, let's call it storage traffic in this case. And this storage traffic is going to be offloaded to the RDMA NICs for extremely high performance. We've also got 2 regular 10 gig NICs that we're using for VM traffic. And the reason we've isolated those 2, so we've got 2 RDMA capable NICs and 2 10 gig NICs, is because up until 2012, up until 2016, we haven't been able to virtualize and pass through the RDMA capability through to a VNIC, whether that be a VM or whether that be on the management OS. If we look inside a 2016 host, you'll see we've converged the networking even further to reduce the number of NICs. So essentially, this server has just got 2 RDMA NICs. They could be 10 gig, 40 gig. Going forward, they could even be 100 gig.
So I want to interject one thought for you. RDMA, if you're not familiar with RDMA, right? So a lot of people go, what is RDMA? How is that different than a 10 gig NIC? Most TCP/IP traffic, and so just take typical SMB traffic, goes through the TCP/IP stack to get to a host. So you've got latency and overhead involved in going through those layers of TCP/IP. RDMA stands for Remote Direct Memory Access. And essentially what it allows you to do is bypass a significant chunk of the TCP/IP stack. So if the current host, the sender and the receiver are both RDMA compliant, they can realize that and they can go, you know what, you do RDMA, I do RDMA. Let's skip a whole bunch of the TCP/IP churn and just get this data to you as quickly as we can. And so the result is you lose a lot of the overhead of TCP/IP. You get to move a lot more data a lot more quickly because it goes almost directly RAM to RAM, hence the term Remote Direct Memory Access.
Yeah, so good context. So yeah, that's really accelerating performance. But you think, okay, that's very beneficial if you think back to our storage module earlier where we had Hyper-V host connected over the SMB network to scale-out file server to our storage backend. That combination, utilizing RDMA for that, would be very beneficial. The performance would be incredibly fast. That consideration, how can we do that if we want to converge down to just 2 RDMA NICs? Because in 2012 R2, you couldn't bind a vSwitch, a Hyper-V vSwitch, to an RDMA NIC and still retain that RDMA functionality. It was disabled. In 2016, as we can see from the graphic here, we've got this new capability built into Hyper-V to enable you to essentially say, okay, I'm going to use just 2 NICs in the host, RDMA capable. I'm going to bind a vSwitch to that host, to those 2 NICs, team them, obviously. And you'll notice that the teaming has converged from left to right on the graphics there as well. So we're now building more teaming capability into the Hyper-V vSwitch to make things more efficient and streamlined. So we've got this single entity, the Hyper-V vSwitch, which is including those multiple RDMA NICs. And then the host OS, the management OS, we've created a host VNIC, just a regular one for regular TCP/IP traffic, whatever it may be. But we've also created 2 host VNICs, so virtual network adapters for the host, VNIC 1, VNIC 2, that have got RDMA enabled. So these are host VNICs. We're passing through RDMA with native performance and really allowing you to still take advantage of connection to the SMB backend file share storage, whatever it may be.
And really what you're left with here is a simpler configuration.
Much simpler configuration.
You have 2 cables, 2 NICs.
Yep.
You get everything as opposed to having 4 cables.
But plenty of bandwidth.
Yep.
Because you're using things like quality of service to say, okay, SMB traffic, you get at least 60% of my 20 or 40 gig. TCP/IP, you get 10%. Management, you get 1, or whatever it may be. So a lot of flexibility there. And then we wrap up in this module with management. And this is becoming pivotal. And this is the biggest thing, the biggest change in Windows Server 2016 is that control of all of these network infrastructure components. If we think about where we were and introducing that ability to manage and deliver services on top, Virtual Machine Manager provides a lot of control, a lot of management, monitoring, orchestration of those networking components. But there's also this programmatic layer where we want to be able to control all of those virtual appliances, the services, and so on that we talked about earlier on. And that's where the network controller really comes in. And the network controller will integrate with Virtual Machine Manager. You can also query it through that REST API, through PowerShell. Your developers can utilize it as well because it's standards-based, so I could pass in a JSON template that would automatically deploy all of my relevant network components. I've got a lot of flexibility. If we think about administrative process, the administrator says, okay, I need to deploy a new firewall rule across all my VMs. I'll write that rule in a PowerShell or a JSON template, fire it at the network controller. The network controller will distribute that firewall rule, that load balancer, VIP policy, whatever it may be. It will control all of that deployment across this, in this case, a very vast multi-tier line of business application. So it's really, as the name suggests, really controlling all of those aspects of the network infrastructure.
It's, another step towards this notion of declarative configuration.
Yeah.
You don't worry about how, you just worry about what you want. And you let the software worry about how you actually get there.
Exactly, and you're providing that level of programmatic control. And if we look at this graphic here, you've got your network controller, and it's got so many touch points in so many different areas. So the Hyper-V host, it's deploying things like firewall rules. Top of rack switches through OMI, it's helping you to configure those. The routers, all of those key components across vSwitch, Hyper-V host. It's not just about management, but it's also about automation to manage, configure, monitor, and troubleshoot the virtual and physical network infrastructure of your environment. Now, if you're wanting to test this out going forward when the technical preview does become available for you, it can be deployed as a single VM, obviously not at production scale for a lab, or as a cluster of 3 physical servers or 3 VMs distributed across separate hosts. So you think, well, why would you need so many? Well, think about how mission critical it is. If it's controlling so many of those components, the firewall, the software load balancer, the top of rack switches, the policies that get applied to the Hyper-V host, that controller is a fundamentally pivotal part of the entire infrastructure. And if we look at what it is, okay, highly available, scalable, when you deploy more than one. Southbound APIs for the network controller to communicate with those key pieces of the infrastructure. Northbound APIs, REST APIs for you to communicate through PowerShell, through templates, or whatever it may be. So with the southbound API, it's going to go out and it's going to discover the stuff in your environment, the network devices, the configurations you've got, all the information about that network. And that's a pathway for you to apply your policies down to those relevant components that it's discovered. So for instance, deploy the firewall policies. But the northbound API, the REST interface, is where you say, okay, I want it to deploy this firewall policy. I want to monitor, I want to troubleshoot the environment, deploy new devices, deploy virtual appliances, and so on. And there are multiple ways to interact with it. PowerShell through the REST API, VMM will interact with it, Operations Manager for monitoring, and so on. There's a lot of capability being built in. And what can it manage? Hyper-V VMs and vSwitches, physical network switches, routers, firewall software, VPN gateways, and so on. And if we think about the features in this all-encompassing graphic, from a fabric perspective, at the foundational layer, the plumbing, subnets, VLANs, layer 2, layer 3 switches, the VNIC, the host network adapters, not VNICs, network adapters. So even if you're using just physical network infrastructure. The firewall, I need to deploy a new allow or deny rule, outgoing, incoming traffic, we can log that traffic, and it's plumbed into the vSwitch of the VMs or at the host layer, depending on your configuration. It will go away and discover topologies and present you with very graphical, rich views. Obviously, you would need some kind of interface. You couldn't just deploy see a topology in PowerShell just through like ASCII text style. You would need something like VMM or Azure Stack to realize that. But the monitoring is very, very rich across physical and virtual, aggregating loss, latency, baselines, deviation, localizing faults that occur between devices. All of that can be bubbled up into something like System Center Operations Manager. So really providing us a lot of granularity there. Service chaining is something else that can be controlled by the network. So if you've got specific traffic that you know needs to pass from A through a virtual firewall, through an agentless antivirus, a virtual appliance, and then on to B, you create these rules that essentially instruct that. So it's called chaining of service chaining between appliances. So I say, okay, this packet needs to go from there, through this appliance, through that appliance, through that appliance, and on to its final destination. You can define all of that using the network controller. The load balancer is configured through the network controller. Ability for me to say, okay, this is the virtual IP front end for the load balancer, and these are all the places where this traffic should be distributed to. Maybe it's a SharePoint farm, maybe it's just a set of web servers, whatever it may be. And then finally, virtual network management and gateway management. So virtual networks, deploying Hyper-V network virtualization, deploying the virtual switches, VNICs to virtual machines, the policies, support for NVGRE, the encapsulation that we use today, but also VXLAN. So VXLAN is another popular encapsulation technology that exists in the industry for network virtualization. The platform integrates with that as well. So very heterogeneous, not just about a Microsoft platform. And then finally, the gateway management. The Windows Server Gateway providing bridging out of the virtual network onto the internet, site-to-site VPN, point-to-site VPN, layer 3 forwarding, all sorts of routing technology as well, load balancing of those site-to-site and point-to-site connections as well. A whole load, just that slide alone is a representation of just how much the network controller can provide and control within this infrastructure. Incredibly powerful. So just like we had on the storage side, we've got some resources. You can provide your user voice. If you think, well, okay, I've been playing with networking for a while, I wish it did this, I wish it did that. Again, you can learn more and provide your feedback. And obviously there's further reading on TechNet as well. But that brings us to the end of day one.
Day one. That was a heck of a module there.
It was a whistle-stop tour.
That was.
But I wanted to get it out of the way.
Yeah, there's a lot of stuff in there. I mean, obviously, the scope of what's included in networking now is so vast that, I mean, we could spend 3 days on networking alone.
Possibly.
But want to make sure everyone gets a good idea of, okay, here's what's new, here's kind of the vision, here's what we're thinking.
Yeah.
This notion of the network controller being the all-encompassing entity that governs everything, and getting used to those concepts.
Yeah.
I think the average guy is not quite there yet.
No, not at all.
But these, as we talked about, virtualization and storage many years ago, this is what's coming down the road. So, get used to it now, understand it, start learning the basics, and you'll have a much easier time when this does become sort of the mainstream way of doing things.
I think the key takeaways from that module are network virtualization is very much here, and you can try it today and start getting used to deploying VM networks and so on. Then you've got, think about your hardware. If you are going to invest in new hardware going forward, new network infrastructure, think about these converged patterns that you can deploy to really simplify your overall infrastructure. And what I gave you was just one example, going down to 2 RDMA NICs, for which you then create host VNICs to create different subnets for different traffic types potentially, and allowing your VMs to communicate out of those same pipes as well. Think about those and think about the offloads that you can take advantage of now and in the future. In addition to that, think about, okay, how am I going to automate my network? How do I load balance? How do I provide security for the network? And just remember that they're going to be built into Windows Server 2016. The network controller, the virtual firewall, the software load balancer, all of those capabilities coming in to the platform to enable you, if you want to go down that more granular route and more automated controlling managed infrastructure, it's going to be there for you.
I would say, find your router and switch guys and take them to lunch. Because
yes.
When all this comes to fruition and you start deploying and working with all these things, you guys are going to be using the same tools and the same methods and the same everything.
Yep.
So they're no longer going to be the switch guys and the storage guys and the Windows guys, and it's going to be the fabric guys.
Yep.
And you're all going to use the same tools and same standards for everything.
Yep. And tomorrow, so we'll carry on the course tomorrow. So day 2. We've got a couple of extra modules for you. We're going to look at Nano Server in the morning.
Nano Server, I can't wait. Nano Server is just fun.
Nano Server. Then we've got containers. So we'll walk you through what containers are all about. We'll do some demos, show you how easy it is to build new containers and what they can be used for. And then we'll wrap up with some automation and show you what's new in PowerShell, PowerShell Workflow, DSC, and so on, and what that can do for you.
Excellent.
But yeah, that's today wrapped up. We'll see you tomorrow, I guess. There's nothing more for us to say. Thank you very much for watching. We will make the slides available as soon as possible. But yeah, if you missed any of it, don't worry, it will be available on demand. And we will see you again bright and early tomorrow. So thanks for joining us.
9 o'clock Pacific, your time wherever.
Thank you. See you later.